You're standing outside at midnight. No streetlights, no phone screen, no glowing apartment windows across the road. Just cold air, a black sky, and that pale white shape hanging above you, the thing humans have stared at for as long as humans have had eyes. And then, without warning, it disappears. Not behind a cloud, not during an eclipse, gone. For 1 second, nothing happens. Then another, and somewhere on Earth, someone looks up and thinks, wait, where did the moon go? Because here's the thing. If the moon suddenly vanished, the first disaster would not be werewolves losing their scheduling system. Although honestly rough night for them, this is not just a story about darker nights. It's not just about tides getting smaller, and it's definitely not just about poets having to find a new object to emotionally overuse. This is the story of how deeply the moon is wired into Earth, into our oceans, our climate, our calendars, our animals, our evolution, and maybe even the stability of civilization itself. Because the moon is not decoration. It is not a lamp. It is not just a pretty rock doing laps around us. The moon is one of the quietest machines keeping Earth familiar, and if it vanished suddenly, Earth would survive, but it would not remain the same planet. Here's the first weird part. If the moon disappeared right now, you technically wouldn't know for about 1.3 seconds. That's how long light takes to travel from the moon to Earth. So for just over a second, the universe would still be lying to you. You'd still see moonlight that was already on its way. You'd still feel the moon's gravity exactly as it was. Then the last reflected sunlight from the lunar surface would reach Earth, and the moon would blink out. At almost the same moment, its gravity would stop tugging on us, not instantly in the magical sense since gravitational changes also propagate at the speed of light, but practically, for humans standing under the sky, the delay is barely enough time to say, uh-oh. Now, would Earth go flying out of orbit? No, that's the good news. The moon is important, but it isn't what keeps Earth orbiting the sun. The sun does that. The moon's gravity makes Earth wobble around a shared center of mass called the Earth-Moon barycenter, which sits inside Earth about 4,700 kilometers from Earth's center. So without the moon, Earth would lose that small monthly wobble. Its path around the sun would shift slightly, but not dramatically. We are not getting launched into Jupiter. We are not spiraling into the sun. Your rent tragically would still be due, but the oceans would notice. Let's talk about tides. Most people know the moon causes tides, but the real picture is stranger than that. The moon doesn't simply pull the ocean upward like a magnet yanking water. Tides happen because the moon's gravity pulls differently on different parts of Earth. The side facing the moon is pulled slightly more strongly. The far side is pulled slightly less. That difference stretches the ocean into 2 tidal bulges, one roughly facing the moon and one on the opposite side of the planet. As Earth rotates through those bulges, coastlines experience high and low tides. That's why many places get 2 high tides a day, not because the ocean is sloshing randomly, but because Earth is rotating through a gravitational shape. Now remove the moon, those lunar tidal bulges start collapsing. The sun would still create tides, but solar tides are much weaker. The moon's tide-generating force is more than twice as strong as the sun's, so Earth would still have tides, just smaller, much smaller. In many places, the daily rhythm of the sea would grow quieter, flatter, less dramatic. Coastal ecosystems that depend on the regular flooding and draining of tidal zones would be thrown into crisis. Mudflats, salt marshes, mangroves, tide pools. Whole biological neighborhoods built around the moon's schedule would suddenly lose their clock. Imagine being a crab whose entire evolutionary strategy is basically trust the moon, and then one night the moon quits. That's not an inconvenience, that's a system failure. And it gets messier. The ocean wouldn't calmly say, lunar gravity has been discontinued, adjusting accordingly. Water has momentum. Coastlines amplify tides differently depending on their shape, depth, and geography. Some places barely notice normal tides. Others, like the Bay of Fundy in Canada, experience enormous tidal ranges because the basin shape resonates with the tidal cycle. So if the moon disappeared suddenly, the immediate ocean response would be chaotic. Not necessarily a global wall of water swallowing continents, since that's movie logic, and the open ocean tidal bulge isn't a kilometer-high mountain of water. But coastal currents, tidal channels, estuaries, and shallow seas could see dangerous surges, strange withdrawals, and violent sloshing as the ocean adjusts to a new gravitational reality. Ports would be disrupted. Navigation patterns would change. Fishing grounds would shift. Some coastal ecosystems would dry out more often. Others would flood differently. And after the initial adjustment, Earth would settle into a new normal, a planet with mostly solar tides, where the ocean still moves, but no longer breathes the way it used to. Now, darker nights sound minor compared to ocean disruption. But darkness matters. For billions of years, life on Earth has evolved under a sky with lunar cycles: full moon, new moon, waxing, waning. That rhythm isn't just aesthetic, it's biological information. Corals use moonlight to synchronize spawning. Many reef-building corals release eggs and sperm into the water at the same time, often tied to the lunar cycle, and the timing has to be precise. If you're a coral, romance is basically logistics. Sea turtles hatch and use light cues to reach the ocean. Some birds migrate using celestial navigation. Predators hunt differently depending on moonlight. Prey behave differently too. Lions, owls, bats, moths, plankton, fish, entire food webs subtly shift with the brightness of the night. Remove the moon, and every night moves closer to a permanent new moon. The stars would appear brighter. The Milky Way would be more visible from dark places. Astronomers would be thrilled. Nocturnal prey animals might feel safer under darker skies. Some predators would struggle, others would adapt. But the point is this: the moon isn't just in the sky, it's in behavior. It's in reproduction, migration, fear, hunger, timing. For countless creatures, the moon isn't scenery, it's a calendar written in light. And humans? We would notice the cultural loss almost immediately. No moon means no lunar eclipses, and no solar eclipses either, at least not caused by the moon. That perfect cosmic coincidence, the sun being about 400 times wider than the moon but also about 400 times farther away, would be gone. No total solar eclipses racing across continents. No ancient terror as daylight disappears. No eclipse expeditions. No diamond ring effect. No corona blazing around a black circle in the sky. Just the sun, exposed and ordinary. We would lose the object that anchored some of our oldest calendars. The word month itself comes from the moon. For ancient peoples, the moon was the easiest clock in the sky. The sun tells you the day and the year, but the moon gives you something human-sized in between. A cycle you can watch, a rhythm you can count, a way to plan planting, rituals, travel, hunting, festivals, fasting, debt, storytelling. Before atomic clocks, before mechanical clocks, before written calendars hanging on kitchen walls with appointments circled in red, there was the moon, changing shape night after night. Lose the moon and modern timekeeping survives, but something older breaks. The sky becomes less readable, less intimate, less companionable. The night loses its face. But the scariest consequences aren't immediate. They unfold over deep time because one of the moon's most important jobs is invisible. It helps stabilize Earth's axial tilt. Earth's axis is currently tilted about 23.5 degrees, and that tilt gives us seasons. Not because Earth moves much closer to or farther from the sun, but because different hemispheres receive sunlight at different angles through the year. Earth's tilt isn't perfectly fixed, it wobbles slowly, but the moon's gravitational pull helps keep that wobble relatively controlled. Without the moon, Earth's axial tilt could become far more chaotic over millions of years. Not overnight, not next Tuesday, you wouldn't wake up to Antarctica at the equator, but over long stretches of time, Earth's tilt might wander far more dramatically than it does now. And that would be a climate nightmare. Imagine a planet where the poles sometimes receive far more sunlight, or where one hemisphere swings through extreme seasons, or where ice ages and heat waves are driven not just by greenhouse gases or orbital cycles, but by a wildly shifting planetary lean. At low tilt, seasons grow mild, but the poles can grow colder and ice can expand. At high tilt, seasons turn brutal. Summers could bake regions under continuous sunlight. Winters could freeze them under extended darkness. Agriculture, which depends on predictable seasons, would become harder to sustain. Ecosystems would be forced into constant long-term adaptation. Civilization likes stability. Farming likes stability. Cities like stability. The moon is part of why Earth has had enough climate stability for complex life and human civilization to flourish. Not the only reason, but a major one. And that's the uncomfortable truth. The moon may be one of the reasons Earth has remained Earth-like for so long. Now let's clear up one common misconception. If the moon disappeared, Earth wouldn't instantly stop rotating. The day would still be about 24 hours long. Your alarm clock would still be offensive in the morning. But the long-term relationship between Earth and moon would end. Right now, the moon is slowly moving away from us, about 3.8 centimeters a year, because tidal interactions transfer rotational energy from Earth to the moon. Earth's rotation is gradually slowing. The moon's orbit is gradually expanding. It's an ancient gravitational trade. Long ago, Earth spun faster and days were shorter. Hundreds of millions of years ago, a day may have been around 21 or 22 hours. Billions of years ago, much shorter still. The moon has been acting like a brake on Earth's rotation for eons. Not a dramatic brake, a cosmic one. Slow, patient, relentless. Remove the moon, and most of that braking disappears. The sun would still raise tides and slow Earth a little, but far less effectively, so Earth's 24-hour day would become much more permanent. The planet would keep spinning at nearly the same pace for an extremely long time. This sounds harmless, and compared to climate chaos it mostly is. But it's another reminder that the moon isn't passive. It has been editing Earth's rotation for billions of years. Every day you experience is partly shaped by the moon. There's also a deeper question. Would life on Earth have evolved the same way without the moon? That's where things get speculative, but fascinating. Some scientists have argued that strong tides on early Earth may have helped create dynamic coastal environments, places where water repeatedly flooded and evaporated, concentrating organic molecules and creating chemical conditions that could have mattered for the origin of life. This isn't settled science. The origin of life is still one of the biggest unsolved mysteries we have. But tidal zones are interesting because they create cycles. Wet and dry, concentrated and diluted, hot and cool, stable and unstable. Life seems to like gradients. Life likes edges. Life likes places where chemistry gets pushed out of equilibrium. And the moon gave early Earth powerful edges. If Earth never had a moon, maybe life still appears. Maybe it appears differently. Maybe it takes longer. Maybe complex life struggles under a less stable axial tilt. Maybe intelligence evolves anyway. Or maybe the moon was one of the quiet conditions that made us possible. That's the humbling part. We tend to think of the moon as something humans looked up at after we evolved. But it may also be something that helped shape the conditions under which we could evolve at all. We didn't simply inherit a planet with a moon. We may be, in some indirect way, children of that pairing. Here's the uncomfortable part. If the moon vanished, the disaster wouldn't look like most disaster movies. There would be no instant fireball, no global earthquake cracking the planet in half, no oceans floating into space. No dramatic shot of the moon exploding while people in New York look up and scream, because apparently every cosmic disaster must be witnessed from Manhattan. The real disaster would be slower. Ecological confusion, collapsed lunar rhythms, weaker tides, disrupted coasts, no eclipses, no moonlit nights, a darker planet, and then, over immense time, a less stable climate system. The terrifying thing about losing the moon isn't that Earth would instantly die. It's that Earth would become less regulated, less familiar, less synchronized. The catastrophe would be partly physical, partly biological, and partly emotional, because we would lose the only world beyond Earth that humans have walked on. We would lose the object that pulled our oceans, marked our months, guided our ancestors, inspired our myths, and taught us that another place could be reached. A moonless Earth would still be alive, but it would feel orphaned. So what if Earth suddenly lost its moon? The honest answer is this. Immediately, the sky goes dark. Seconds later, lunar gravity vanishes. Within hours and days, tides begin reorganizing into weaker solar-driven patterns. Coastal ecosystems and marine life face disruption. Nocturnal animals lose a major environmental cue. Human culture loses one of its oldest symbols. Over millions of years, Earth's axial tilt may become far less stable, potentially creating extreme climate shifts. And over even longer timescales, Earth becomes a planet with a different future. Not dead but altered. Not uninhabitable overnight, but less protected from chaos. The moon isn't necessary for Earth to exist, but it may be necessary for Earth to be the version of Earth we know. And there's something almost poetic about that. The moon doesn't shine by itself. It reflects. It borrows light from the sun and sends it back softly enough for eyes to love. It moves oceans without touching them. It steadies a planet without announcing itself. It shapes life without asking to be noticed. For most of history, humans looked at the moon and saw gods, rabbits, omens, lovers, calendars, madness, mystery. Then we built rockets and discovered it was rock, dust, basalt, craters, silence, and somehow that made it even more miraculous, because the moon doesn't need to be magic to be sacred. It just needs to be essential. So go outside on the next clear night. Look up. That pale shape above you isn't just scenery. It's a tide maker, a clock, a stabilizer, a fossil of Earth's violent youth, a partner in the long story of life. And if it vanished, Earth would keep spinning. The oceans would keep moving. The sun would still rise. But the night would feel wrong, because sometimes the things holding your world together aren't the loudest things. Sometimes they are silent, distant, covered in craters, and glowing softly in the dark.